Okay. We ready? Guys, we are going to perform some transformations, but we are not going to use coordinates. Okay, when we don't use coordinates, it's something called synthetic geometry. Okay. A transformation involves moving all of the parts of, all the points that make up a geometric figure according to the same rule. Like we translate along a vector. We rotate the whole figure about a point. We reflect the entire figure in a line. Okay, they're all going according to the same rule. And then the original figure is our pre-image. Have we talked about this yet? And the transformed figure is the image. Okay, so if you were thinking about like algebra 1, like x and y, input, output, which of these is the input? Yeah, the pre-image. This is the input. Okay, and then the transformation is kind of like the function rule that we apply to the input, and we of course get the output. So just like we transform all of the inputs according to the same rule, we would transform all points in the pre-image according to the same rule. Okay, a rotation needs a couple of things. In order to perform a rotation, you need to know the point about which we're rotating. Okay? Okay, really quick, sorry. Sometimes my board is acting up. Okay, hopefully that fixes it. Okay, the next thing we need to know is an angle measure that tells us how far to rotate around that point. Makes sense, right? The last thing we need to know is which way to rotate. Are we going to go clockwise or counterclockwise? Now, in math, counterclockwise is the positive direction. Okay, clockwise is actually negative. And the quadrants actually go in that order. Have you guys seen like where everything is positive, that's the first quadrant? Okay, and then it's the second quadrant, the third, and the fourth. Like you're doing a C for coordinates, right? So the positive direction, and then the way we number the quadrants, it's both counterclockwise. Everybody happy with that? Okay. And you will learn more about that when you get into pre-calc, when you start doing stuff with the unit circle. So, yay, more on that to come. All right, so here we have a cute little rotation that we have to perform. We have to rotate the figure, which is a segment PQ, about point O. And we're going to go 40 degrees counterclockwise. So that is in the positive direction, opposite of a clock. Okay, we have function notation for this. Unfortunately, rotation and reflection both start with R. So whenever we do rotating, it's going to be a lowercase r. Okay, so this is another one of those times where it doesn't matter if I use a capital or lowercase r. Oh yeah, okay, because if you use the wrong one, you mean something totally different. All right, so nice big lowercase r, because then we need a subscript. It's like an exponent but low, okay, so it's little. Okay, we're going to go positive 40, so we can just say 40 degrees, and then a comma, and then we say which point we're going around, O, and then we close the parentheses. So all of that information, the direction of the turn, the size of the turn, and about which point we turn, it all goes in the subscript in parentheses. All of that information. Okay, and then the last thing, we're out of the subscript, we're back up on the main line, is the name of the figure that we are transforming. So it's segment PQ, normal size. Okay, any questions about that? Easy peasy? Okay, does everybody have compasses and straight edges? If you don't, get them out. If you left yours at home, go borrow mine. You also need your protractor. Wow. Oh, sorry. Okay. So the first thing I want to figure out is my angle, like how far do I turn? Because once I know how far I can turn, I can just copy this distance in that direction, okay? So what I'm going to give myself is a little auxiliary line where I can line up my protractor and measure an angle. So I'm going to anybody have a problem with me doing point Q first? Okay, good, because that's what's happening. I'm going to go through points O and Q. I realized that I missed, but now it's right. Okay. Now, which point am I spinning around? O. So the center little bit of my protractor needs to go on O, not Q, or you're going to be in a world of hurt. And I'm going clockwise, so I don't want my protractor going this way so that I'm turning the wrong direction. You see what I'm saying? I want to turn 40 degrees this way. So I'm putting 0 degrees right on point Q. Okay? Back to my pencil. With my pencil, I am marking 10, 20, 30, 40 right there. Okay, move your protractor out of the way. Okay, now I'm going to go with another auxiliary line through point O, and then this point 40 degrees away that I just made. Okay, so this right here is my 40 degree turn counterclockwise. Okay, now I can't just put Q anywhere on this line. I want to make sure it's the same distance from point O here, right? I can't just put Q prime anywhere. So this is when I need my distance copier. I'm copying the distance from O. Whoa, that's my protractor. From O to Q. Okay. Oops. Everybody see it? Okay, that is the location of my Q prime. Okay. Now, can you see that P is going to be somewhere like right over here? It's going to kind of go around in front. We're going to do the same thing for P. So I need another auxiliary line going through points O, and whoops, I don't want pink this time. I want pink. Let's go back to black. Going through O and P. Okay, get your protractor. The center goes on O. This time it's point P. Whoops, how do I spin it? It's over here. Spinning is here. This time it's point P that we put on 0 degrees. Okay, now I'm going to go blue so we can tell the difference. So in the counterclockwise direction, opposite of a clock, I'm going 10, 20, 30, 40 degrees. Make a little tick. Okay. Okay, use your straight edge. You are connecting points O in the little tick you made. So this is another 40-degree rotation counterclockwise. Am I going too fast? Okay. Okay, who can tell me what my next step is? How do I find where on that auxiliary line to put P prime? Yeah, measure it with the compass. Very good. All right, so I'm going to measure my distance from O to P so that I know how far away P prime has to be. Okay, I just copied that distance. And that is the location of my P prime. Okay, the only thing left is that PQ is a segment, so P prime, Q prime should also be a segment, so we should connect those points with a segment. Oops, I meant to be on my line. Please use your straight edge. The one thing that's easier for me on this board than it is for you with the physical tools is that I don't need a straight edge. I can just connect it with the straight line tool. But you don't have that, so you have to use the straight edge of your protractor. Yes? Okay, are we good? All right. This time, guys, we are going to go clockwise. So if counterclockwise is the positive direction, clockwise is the negative direction. So instead of being positive 160 degrees, this will be negative 160 degrees. So when we do our function, we have to make sure if it's clockwise, we do negative for the angle, because otherwise we'll go the wrong direction. Okay, so my function notation, great big little lowercase r. Okay, That way I can tell your subscript is a subscript. Otherwise, it's hard for me to tell. Open your parentheses. You're going negative 160 degrees. About which point? M. Close them. Now we go back up to the regular size, regular line. Which figure are we supposed to rotate? Perfect. Triangle ABC. Okay? So the first letter tells us which transformation we're going to perform. The subscript tells us the size of the rotation, like the angle, and which way, and then about which point. And then the tail end, the caboose, tells us which figure is being transformed. Okay, so the entire instructions is right there in that compact little math sentence. Okay, if you forget any of those parts, she don't work, right? We need all those pieces. All right, this time we have 3 points to rotate. What if I wanted to rotate, what if it wasn't point M? What if I wanted to rotate about point C? Would I have to move point C? No, C prime would just be on C, okay? I think you have some like that in your assignments. So if you see one like that, just know I was nice to you and you don't have to move that point. You just get to put C prime and be done with it. All right, but we are gonna go around M, so I was not nice here. Can we start with A? All right, I didn't hear a no, so I'm gonna do A in orange. First thing I need, auxiliary line going through my center of rotation M, straight through point A. Now this is where you have to pay attention because we're going the opposite direction. Okay. And zoom out a little bit more. Hopefully it's not too hard for you guys to see. All right, so I'm going to put the center of my protractor at my center of rotation. Now this time I want to have room to rotate in the same direction as the clock. So I'm going to spin this around this way. Okay, I don't want to go in the positive direction. I want to make sure I have room to go negative. And I'm going almost a whole 180-degree turn. I'm going all the way to 160. So be careful. Don't be fooled by this 160 here. That's only 20 degrees. So 10, 20, 30, 40, yada, 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 yada. 160 is way the heck over here. Okay, move that out of the way. Okay, auxiliary line going through your center of rotation. All the way through your tick. Now I can't just put A anywhere, A prime anywhere on that auxiliary line. I have to make sure it's the same distance from the center of rotation as my original point A. Otherwise my figure will be distorted. I need to preserve all of my side lengths and all of my angles. So if I don't keep the same lengths, it's going to be bad. Okay? So I'm going to use my distance copier. I'm going to copy the distance from M to A. Ooh. Okay, that is the location of A prime. You see that big old angle? That was negative 160 degrees.
Okay, we're gonna rotate points B and C, but I don't know that you need to watch me do it because it's exactly the same as the other ones we've done.
So let's say that I have like a triangle ABC that I want to reflect in this line of reflection right here. Here's my cute little triangle. Here's A, B, and my C. Actually, sorry, I don't want to do that triangle. I want to do a different triangle. Sorry. I want to do one of my points on here. I want to do this triangle. I like this one better. So here's my point A, here's my point B, here's my point C. Okay, now, for it to be a reflection, my points have to end up on the opposite side, the same exact distance away. Now, when we say distance from a line of reflection, we're talking perpendicular distance. So can I measure the distance from A to my line of reflection this way? No, because it's not perpendicular. A is not that far from the line of reflection. I have to go perpendicular distance. It has to be a 90-degree angle. Everybody see what I'm talking about? Okay, you can't do other weird angles because then your distances won't have a standard angle. Okay, so if I go the exact same distance away on the other side and copy that distance to get my A prime, what is going to be true about this distance and this distance? They are congruent. The distances are the same. Those segments are going to be congruent. That matches that. Okay, now, do you see that my line of reflection is my perpendicular bisector for the segment A prime? Boom. Okay, look at point C. Okay, 90-degree distance. Make sure it's a right angle. Reflect it to the other side. Same distance away, C prime, 90 degrees. What's true about this distance and this distance? They are the same. Those measures are equal. My line of reflection is the perpendicular bisector for the segment C prime. Everybody with me? Okay. What happens to point B? If it's on the line of reflection, it's a short trip. He doesn't go anywhere. Okay. He just gets to stay right there. B prime is right there. So when I connect my little points, I get the mirror image. Okay? The line of the reflection is the perpendicular bisectors for the segments that connect my pre-image point to my image point, my corresponding image point. Everybody got that, like, ingrained in your brain? Do you see that if these are both perpendicular to the same line, that they are parallel? Okay, here we go. Now we're going to have some fun. All right, we kind of already know how to do this. What we don't know how to do is not, like, guess it, but use a compass to do it. I'm struggling. I just wanted to get my tools. I have to go tool shopping every time I switch pages. Can't bring my tools with me. Okay, so what I want to figure out is a point on the opposite side of line M that's going to be my P prime. Okay, so what I'm going to start out by doing is putting my metal tip on point P. I'm going to select a radius that won't get me off of line M. Okay, so you want to make sure that both ends are going to be on line M. Okay, once you pick this radius, thou shalt not change thine radius. because then thine point will not be reflected. It will be warped. All right, so I'm going to do a tick on this side, and then a tick down here. Oops, too far. Oh, shoot. Oh, shoot. I just messed it up. I hit the change my radius. You know how I said don't change your radius? Guess what I just did? I did. It was mortifying. Okay, so there's my 2 ticks. Now, pretend that this is a segment, because it is. You guys know how to do a perpendicular bisector for a segment, right? Can't we just do a perpendicular bisector for that segment that we just made? Okay, and then P and its image, P prime, should be on that perpendicular bisector. So don't change your radius. Okay? Metal point on your first tick, the intersection of your first arc and your line M. Don't change your radius. Do a little arcy. Okay? Metal tip on your intersection of your second arc with line M. Don't change your radius. You want your arc to intersect with your other arc. That's P prime. Okay, can you draw the segment through P and P prime to connect them? Yes. Do you have to? No, unless they're telling you to construct that. All we need to know is that point. But we're using the perpendicular bisector thing to make it happen. Okay, but we don't need the whole picture, we just need the crisscross. All right, everybody happy with that? All right, so the function notation for a reflection, big capital R. Okay, in your subscript, you have to tell me the name of the line of reflection. What line did we just reflect in? Yeah, line M. So, line M. Okay, give me the scripty M, not a capital M or anything weird. You have to call it, it's a scripty M, lowercase scripty, you got to give me lowercase scripty. Okay, what is the name of the figure that we reflected? Point P. Okay, ready for another one? Actually, I'll let you guys practice. Do some practice. We'll finish tomorrow. We did good. Congratulations.